Hello, ladies and gentlemen, and just wanted to recap some things that we're talking about today. So this was part of your homework that I gave for both period 1 and period 2. And period 2, we had a really good discussion about how to do workbook page 153, and I added it to your homework. And so period 1, what I want to do is catch up with you guys and talk to you a little bit about what we did on 153 and also add it to your homework tonight. So let's take a look at it real quick. Identify the types of function defined by the following equations. We can't read that very well, so I'm going to zoom in a little bit better. Maybe we'll come in. There we go. So, identify, maybe one more time. Hey, beautiful. Identify the type of function defined by the following equations. Is it either linear, quadratic, square root, reciprocal, exponential, or neither? So they want us to identify it. If the equation represents a linear, quadratic, square root, reciprocal, or exponential, sketch the function of the base function. Sketch the graph of the base function. Okay, so that seems a little odd, but let's take a look. Now remember, these are all your primary functions. And you were doing your homework tonight, I'm sure, and you're going over it, and you're going to be able to find your quadratic function. Your quadratic function is x squared, your base function, and so it's going to have a vertex of 0, 0, and open up. Your exponential function, we talked about it today. It goes like this, okay? It goes through 0, 1. The root function was brand new. It comes out like this, and again, this is part of your homework. And your reciprocal function was the function that came like this, and came like this, and had the points 1, 1, and -1, -1. So, over here, they want you to look at these and say, which base function do these look like? Now, this is y equals 3x to the minus 4. Its base function is going to be y equals 3 to the x. That's its base function. You don't have to worry about that -4 right now. That's going to do something to it, and we're going to talk about it. But right now, this question just asked us to determine the graph of the base function. This is an exponential function. Okay? And it's an exponential growth, so it's going to look like that. It's going to go through the point 0, 1, because no matter what the base is, if the exponent's 0, then it's 1. And just so that we know a little bit more about this one, if x was 1, this point here would be 1, 3. Notice it's not 2 because the base is not 2. The base is 3. So if x was 1, it would be 3. Over here, if it was -1, then it would be 1/3. And that's the function. Now this -4, I'm not worrying about it right now. It will do something. It'll take this graph and it'll move it 4 places to the right. It's actually going to pick it up and go this way 4 units. Don't have to worry about that right now, just worried about the base function. Let's take a look at B. Now, look at this +3 and this -8. We're going to ignore that right now. This base function would simply be y equals 1 over x, which is what we call the reciprocal function. It looks like, and we talked about this today, we saw this for the first time, and we were able to determine that it has the point 1, 1, and it goes like this. And it has the point -1, -1, and it goes like this. And that's the base function. That is the reciprocal function 1 over x. Now this -8 is going to shift the whole thing down 8, and this +3 is going to move it 3 to the left. We remember a little bit about that from grade 10. So that's all that this question's asking you for. So look at this one. This is going to be an exponential. No, it's not an exponential function. This is a quadratic function. Its base function is y equals x squared. So the base function is going to look like this. Vertex 0, 0, and it opens up. We should know another point on it maybe. Maybe 1, 1 is a nice one to know. 2, 4. Now look at this. This negative 2 and this plus 23 and this 3 have nothing to do with what we're going to deal with later on, just the base function. I know that this will take this base function and move it 2 units to the right, 23 units up, and this 3 is going to stretch it by a factor of 3. All of this should be reminding you of grade 10. What about this? Well, this also is a quadratic function. Its base function is simply that. It too is a quadratic. And it looks something like just what we drew. Zero, zero, opens up. That's its base function. Over here, this guy. This base function is going to be 1 over x. It's going to be the same as this one. Same as this one over here. Better come out a little bit because I'm moving over the curve. This one, this is going to be a linear function. Its base function is y equals x. It's linear. And it's going to look, the very base function, y equals x, is the line that when x equals 1, y equals 1. When x equals 2, y equals 2. And it is the line that cuts through quadrant 1 and quadrant 3 at 45-degree angles. That's your base function for a linear. Your base function for this one is going to be y equals root x. So it's going to look like this from what we learned today. So its base function at 0, 0, 1, 1, 4, 2, etc., etc. Now this one and this one, take a look at them. They're not reciprocal because it's got an x on top. It's not quadratic because it's got a 3. We don't know what these are, so these are neither. What basically means that it's none of the ones from grade 11. You'll work with these more in grade 12. This is actually a cubic function that we don't need to work with, and this is actually a rational function, so it doesn't have a name. I'm looking here, I'm seeing a bit of a typo here. Let's pretend that that is 5x minus 7 up there. So we'll make it 5x minus 7, and it doesn't matter what all that is. The base function is simply going to be 1/2 to the x. Anyway, I'll leave the rest for you to work on, and we'll talk about it tomorrow. Thanks, guys. See you then.